Welcome to the second of 9 videos for Chapter 1. This video I'm going to be talking about Section 1.1 of the textbook, Basic Sentential Logic, Informal Fallacies, and Cognitive Biases. And in this video, the topics are going to be what is an argument, types of arguments, specifically deductive versus inductive arguments, and then some categories, so validity, soundness, strength, and cogency. So these are ways that arguments of these two different types, deductive and inductive, can be good or bad. This is probably going to be the longest video of Chapter 1. So arguments are a verbal or written or propositional representation of some episode of reasoning. Now, reasoning goes on in people's heads usually. So the pizza argument, if you recall, from the previous video, was a representation of a piece of reasoning that the girl at the airport was going through. She wasn't speaking out loud. She wasn't saying, this pizza is either cheese or pepperoni. And she may not have even been explicitly thinking that. The reasoning was going on in her head. But if we're going to study that, we need to be able to represent that reasoning. Now, given that an argument is a verbal representation of a piece of reasoning, and that reasoning, as we discussed in the last video, is determining what follows from some facts or assumptions, then we can get the following definition of an argument. An argument is going to be a set of statements such that, one, the conclusion, and I put this in red here because this is corresponding to what follows, is taken to follow from the others, the premises. Okay? So reasoning is determining what follows from some facts or assumptions, so we need to represent both the initial facts and assumptions, and we're going to call those premises, as well as the new thing that possibly follows from those facts and assumptions. We're going to call that the conclusion. So with the pizza argument, this is a representation of that piece of reasoning that the kid was going through at LAX. There were two premises that I've numbered here, 1 and 2. Either the pizza is a cheese pizza or it's a pepperoni pizza. It's not a pepperoni pizza, therefore it's a cheese pizza. Now you'll see I've done a few things here in addition to just represent these things as statements. I've numbered all of them, and I've put the premises first and the conclusion last. That's going to be standard. I've also got this line here separating the premises from the conclusion. And I've also got this triple dot, which is the first symbol that we have. We're going to get a lot of symbols in this course. This means therefore. So it's a way of marking off the conclusion of an argument. Now, any argument is always going to have exactly one conclusion, but there could be any number of premises. You have one premise, two premises. The pizza argument has 2 premises. There could be 10 or 20 premises. As we'll see in Chapter 4, we'll run across some cases where an argument has 0 premises. That's kind of unusual, but there can be any number. Now, it's going to be helpful for us to divide arguments into 2 categories. And the categories are deductive and inductive. And first, I'll give you a rough division. A deductive argument is one where the premises are taken to provide complete watertight support for the conclusion. Okay. Now, that argument may or may not be successful. It might be the case that the premises don't provide complete watertight support for the conclusion. An inductive argument is one where the premises are taken to provide probable support for the conclusion. And again, it might succeed or it might fail. The premises might actually provide probable support, or they might not. I'll say a quick word about this taken to by who, like who's taking the argument to provide watertight support. It's whoever's going through the reasoning. So whoever is going through the piece of reasoning, and we're sort of capturing that reasoning in terms of an argument, that's who counts in terms of whether they're taking it to provide watertight support or not. Okay. So it's kind of like, you know, if somebody bakes something and then they submit it to a baking contest, right? I might submit it to a cake contest, or I might submit it to a pie contest. So if I think it's a cake, I submit it to a cake contest. But then once I submit it to that contest, it gets judged by those criteria, right? If I submit it to a pie contest, it gets judged by pie criteria. So if someone's argument that they're thinking through, if they think it's providing watertight support, then we're going to treat it as a deductive argument and see if it meets the criteria, see if it really does provide watertight support. If they just think that their argument's providing probable support, then we'll judge it according to these criteria. Is it really providing probable support? This is going to turn out not to be a big deal. We'll know pretty much when an argument's deductive or inductive, so don't worry too much about that. Let's get some examples of deductive and inductive arguments. So here's an example of a deductive argument. If I file my taxes, I will get a refund. That's premise 1. Premise 2, I will file my taxes. Therefore, 3, I will get a refund. Now this is deductive because if I'm going through this piece of reasoning, suppose this is my reasoning, I might think that 1 and 2 provide watertight support for the conclusion, and in fact they do. So this is not only a deductive argument, it's a good deductive argument, and we'll talk later about what good means. But compare that to this. This also might be a deductive argument. I might go through this reasoning and think that the conclusion follows with complete certainty from the premises, but you'll see it doesn't, right? If my plants were watered, the hose would be moved. The hose was moved, therefore my plants were watered. Now you should be able to see why this isn't good, right? Maybe premise 1 is true. If the plants were watered, the hose would be moved. Maybe that's the only way to get water to the plants. And maybe the hose was moved, but the plants weren't watered. Someone moved the hose to cut the grass, right? They didn't water anything. But even though it fails, it would still be a deductive argument if the person going through that piece of reasoning thinks it provides watertight support for the conclusion. Here's an example of a good and a bad inductive argument. So here's a good inductive argument. South Park has always been on Wednesday at 10 p.m. It's now Wednesday at 10 p.m. Therefore, South Park is probably on now. Now, if I'm going through this piece of reasoning, I don't think that it's watertight. You might, realize that a show could get canceled. That happens from time to time, or something could go wrong at the cable company. But probably, if you just had to bet money, yes or no, on the conclusion based on the premises, it's probably a good bet. How probable is probable enough? Don't worry about that. We're not going to really be focusing on inductive arguments. We're going to be focusing on deductive arguments. So for our purposes with inductive arguments, we can get by with just a very rough, intuitive idea of something making a conclusion probable versus not. Here's a bad inductive argument. The last time I watched South Park, the first commercial was for Old Navy. Therefore, the first commercial on tonight's episode of South Park will probably be for Old Navy. That's pretty weak. Even if the premise was true, if that's all you knew, I wouldn't bet a lot of money on the conclusion. It might be true, but commercials change all the time. It's not that big of a deal. Now here's the key point, or a key point. The difference between deductive and inductive arguments is not a matter of how good the arguments are. It's not like deductive is good and inductive is bad, any more than cakes are good and pies are bad. These are just two different kinds of argument. Each one could be good or bad. You could have a deductive argument that is horrible, and a deductive argument that's good, and an inductive argument that's horrible, and an inductive argument that's good. The difference is, again, in the degree of support the person going through the reasoning thinks that the conclusion gets from the premises. Now, so far I've been using this word good, like the argument is good or it's bad or the argument fails. That's really rough, and right now we're going to sort of get more clear on what that means and introduce some new terminology. It's going to turn out that for any argument, deductive or inductive, there's two different ways in which an argument can be good. Okay, the first is what we can call for now the inferential relationship between the premises and the conclusion. And I'm going to expand on that in just a minute. The second is the truth of the premises, whether the premises are all true or they're not all true. Let's talk about these one after the other. So first, the inferential relationship between the premises and the conclusion. Think of it this way. You've got an argument. Someone is going through a piece of reasoning. You can express that as an argument. Ask yourself, if the premises were true, would the conclusion necessarily be true? Or would it probably be true? So there's really two different questions here. If it's a deductive argument, you ask the question in terms of necessarily. If the premises were true, would the conclusion necessarily be true? That's the question you ask if it's a deductive argument. If it's inductive, you ask if the premises were true, would the conclusion probably be true? But the form of the question is generally the same. You're asking about this relationship between the premises and the conclusion. Now note, you can assess this even if the premises are in fact false. This question doesn't care whether the premises really are true or really are false. That doesn't matter. We're going to get to whether the premises are true in the second measure of goodness. But the first measure doesn't matter. So for example, let's go back to this argument. If I file my taxes, I will get a refund. Premise 2, I will file my taxes. Therefore, 3, I will get a refund. Now, if these premises were true, the conclusion would have to be true. Okay? Now, maybe I'm going to try to convince you of this in just a minute. But this passes the test for deductive arguments. If you ask yourself, if these premises were true, would the conclusion have to be true? The answer is yes. Another way of putting it is, if the conclusion were false, then at least one of the premises would have to also be false. Now you might be thinking, hey, couldn't the conclusion be false? Right? Maybe I don't get a refund, right? Well, that's right. Maybe there's a legal lien on my income, so I don't get a refund. I don't get a return for my taxes. So that's true, but notice something. If there's a lien on my income such that I don't get a return or a refund, then the conclusion is false. But premise 1 also becomes false, right? If there's a lien on my income such that I don't get a refund, then it's not true that if I file my taxes, I will get a refund. So the situation that makes the conclusion false also makes one of the premises false. Okay, so if we go back here to the definition of validity, it is, if the premises were true, the conclusion would have to be true. Or if the conclusion were false, at least one of the premises would have to be false. This argument passes that test. Yeah, you can make the conclusion false, but only if you also make one of the premises false. The combination, okay, what valid means, if the premises are true, conclusion must be true. Okay, or if the conclusion's false, at least one of the premises has to be false. It's ruling out the combination of true premises and a false conclusion. And if that combination isn't possible for an argument, then that argument's valid. Here's an example where that combination is possible. So we saw earlier, I sort of tried to convince you intuitively that this was not a good argument. Now we can be a little more specific about what we mean by good, which is that even if these premises were true, the conclusion could be false. So remember I said, maybe someone moved the hose to cut the grass. Well, when I said that, what I did is I'm now telling you a situation where the conclusion is false, but the premises are still true. It's still true that if my plants were watered, the hose would be moved. It's still true that the hose was moved, but the conclusion is false. And so because that combination is possible, the argument isn't valid. Now, one thing I want to point out, I said that we can assess this question whether the premises in fact are true or not. So let's go back to the taxes argument again. This passes the test. I try to convince you that if these premises are true, the conclusion has to be true. Notice you don't know whether these things actually are true or not. You don't know if it's true that if I file my taxes, I get a refund. Maybe there is a lien on my income. You don't know. You don't know if I'm going to file my taxes. Maybe I'm not going to do that. Right? I don't like the government and whatever. But it doesn't matter. It doesn't matter if these things actually are true or false. What's important for this first measure, for the whether or not the argument is valid, is you ask, if these were true, would the conclusion have to be true? That's the way to think of that question. So if a deductive argument has a good inferential relationship, if it passes this test, okay, the test being it's not if the premises are all true, the conclusion has to be true, then our word for that is valid. And here's a definition. An argument, a deductive argument, I put deductive in parentheses because we're also going to have a definition for inductive arguments. A deductive argument is valid if and only if, that's not a typo, so I with two F's is if and only if, and it's used for definitions. Here's the definition. If all of the premises of the argument were true, the conclusion would have to be true. Or alternately, if the conclusion were false, then one or more of the premises would have to be false. Now here's an example of a valid argument where, in fact, everything is false. Okay? If I'm president of the United States, then I get all the free BMWs I want. That's a false premise. Okay? There's no provision in the Constitution about president getting free BMWs. Premise 2, I am president of the United States. That's false. I am not president of the United States. Therefore, I get all the free BMWs I want. Now notice this passes the test. If those premises were true, the conclusion would have to be true. Okay? If President of the United States got all the free BMWs they wanted, and I was President of the United States, then I would get all the free BMWs I want. If those premises were true, the conclusion would have to be true. So it is valid, even though everything's false. In fact, it's false. Okay? And I'm just kind of hammering this point over and over because it's a point that's kind of counterintuitive for a lot of people. They generally think of just false equals bad and true equals good, and don't think that way when you're thinking of validity. Everything here could be false, but it's still a valid argument. Here's an argument where everything is true, but it's a horrible argument, right? Premise 1, if I have a mass greater than 0 kilograms, then I am subject to gravitational forces. That's true. I like pizza. That's also true. Therefore, I'm explaining validity. That's also true. But you can see, even though everything here is true, this is a horrible argument. Okay, intuitively, you can just tell this is a bad argument. Slightly less, or not less intuitively, but to not rely completely on intuition, you can see that the reason it's true is that even if these premises were true, the conclusion could still be false. And in fact, later on, I won't be explaining validity anymore. 1 and 2 will still be true, let's say in an hour, but 3 will be false. And because that combination is possible, it's not a valid argument. So here's the possibilities. If an argument is valid, then anything in green is possible, but there's something that's ruled out, and that's really important. So in this column, this is premises are all true, and this is premises are not all true. And then here in row 1, we have true conclusion, and second row, false conclusion. So this square here, is it possible for an argument to have all true premises and a true conclusion? Yeah, valid argument could have that, definitely. It could have, and here's an example, California is either east or west of Nevada. It's not east of Nevada, therefore it's west of Nevada. The premises are all true, the conclusion is true, that argument is valid. So that's a possibility. You can have a valid argument that has all true premises and a true conclusion. Some valid argument could also have not all the premises are true and the conclusion is true. So here's an example. If I'm president of the United States, then I have to teach logic. I am president of the United States, therefore I have to teach logic. Conclusion's true. I do have to teach logic. That's one of the classes I teach. But the premises aren't all true. But that's okay. It's a valid argument. If these premises were true, the conclusion would have to be true. So it's valid. Even though in this particular case, the premises aren't all true. Here's an example where the premises aren't all true and the conclusion is false, right? In fact, we just talked about this argument. This is where everything is false. Premises are false, conclusion is false. If I'm president of the US, I get free BMWs. I am president of the United States, therefore I get free BMWs. It's valid, but everything's false. The one thing, the one combination you can't have is right here if an argument's valid. You can't have all premises true but a conclusion false. Okay? If all of the premises of the argument were true, so suppose we're in this column, then the conclusion has to be true or limited to row 1. This is what this first version of the definition is telling us. It's saying if the premises are true, then the conclusion has to be true, right? We can't be here. The second version of the definition is saying, look, if the conclusion is false, so if we're here on this row, the premises, one or more of the premises would have to be false. So we're not in this column, we're in this column. So both of these definitions, they're equivalent, and what both of them are doing is they're ruling out this square. They're ruling out this combination of all true premises, false conclusion. Okay? So call this combination a situation in which all of an argument's premises are true, but the conclusion is false. We're going to have a special name for that. We're going to call that a counterexample. Okay? And in fact, it's common for people to think of counterexamples. If someone is giving you an argument for something and you're trying to show that their argument is bad, usually people come up with counterexamples, right? And I've kind of done that. So with the hose argument, when I said, well, maybe someone just moved the hose, okay? That was me explaining a situation where, for that argument, the premises were all true, but the conclusion was false. I was saying this argument could be here. And if an argument can be here, it can't be valid. Okay? Here's another example. Roberto says, I know Juan won lotto. I saw Juan in a Tesla this morning, and Juan always said that if he won lotto, he'd buy a Tesla. So Roberto goes through this argument. Maria says, well, look, maybe he just inherited a lot of money. What Maria's doing here, well, first off, let's look at Roberto's argument. If we wanted to take this reasoning and put it in an argument form, it would be something like this. If Juan won lotto, he would have a Tesla. How does he know that? Well, because Juan had told him that a lot. And Juan buys lotto tickets, and he says, this is why I'm buying lotto tickets, because I really want a Tesla. Juan has a Tesla. How does he know that? He just saw him driving around in one. So now he's concluding that Juan won lotto. Now, this is not, even though Roberto might think this is a valid argument, it's not. It's deductive, but it's not a good deductive argument, as Maria is going to show, because what Maria is doing here is Maria is describing a situation where all the premises are true, but the conclusion's false. So what she's doing is she's showing that this argument could be here. And if an argument can be here, it can't be valid. Okay? And she's showing that by constructing a counterexample. A situation where the premises are all true, but the conclusion is false. And so if there's a counterexample, that means the argument could be here. And if it can be there, it can't be valid. And we're going to use this as a test for validity in chapter 2. Okay? What we're going to be doing is we're going to take arguments and we're going to see if it's possible for the premises to be true while the conclusion is false. And If that combination is possible, the argument is invalid. And if that combination isn't possible, then it's valid. We're going to talk more about this in chapter 2. But notice for now this makes sense, right? Because the point of reasoning is to be able to know that some conclusion is true because it follows from some other assumptions, right? So you don't have to check on the conclusion independently, right? Like the girl didn't have to open the box. She just knew that the premises were true and the reasoning was good, so she didn't have to check on C independently. She could get to C, the conclusion, just by reasoning. If there's a counterexample, right, that means that you can't just move to the conclusion from the premises. The premises could be true and the conclusion could still be false, right? So you would need to check if you want to know if the conclusion is true. Okay, that's just intuitively why these counterexamples are important. Now, if we go back to inductive arguments, something very similar. South Park has always been on at 10. It's now Wednesdays at 10. Therefore, South Park is probably on. There is a good inferential relationship between the premises and conclusion. Right? If those premises were true, the conclusion would probably be true. This was the example where it wasn't terribly good. Okay? There's not a good inferential relationship. Just as in the case of deductive arguments, where we had a term if the argument passed the test, and if it didn't, we're going to have that for inductive arguments, which is that they're strong. If an inductive argument passes that first test, it's strong. So here's the definition. An argument, inductive argument, is strong if and only if all the premises of the argument were true, the conclusion would probably be true. Okay? So to recap, we've been looking at the first type of goodness that an argument can have, this inferential relationship. If a deductive argument has it, if it passes its test, it's valid. If an inductive argument has this type of goodness, if it passes that first test, it's strong. Okay? What's the second type of goodness? Well, it's whether or not the premises are true. Okay, so compare these two arguments. The top one is the BMW argument that we've already seen. If I'm president of the US, then I get all the free BMWs I want. 2, I am president of the US, therefore 3, I get all the free BMWs I want. That's valid. But there is still something kind of wrong with that argument. It's not that it's not valid, it is. It's that, in fact, the premises aren't all true. Compare it to this argument. This is also valid. It has the same form, by the way, modus ponens. We'll get to that in chapter 3. If I am over 21, then I can legally drink beer at the pub. I am over 21, therefore I can legally drink beer at the pub. Also valid. Validity, as we'll see, is a function of form, and these two have the same form. That's why they're both valid. But what this one has, the type of goodness this one has over this one, is that not only is it valid, okay, because they're both valid, but only the second one is sound, right? It's valid and all of its premises are true. So this is the second type of goodness, and here's our definition. If a deductive argument is valid, that's test 1, and it has all true premises, test 2, then it's sound. For an inductive argument, if it passes the first test, if it's strong, and it has all true premises, then it's cogent. Okay? And to summarize this in one little chart here, we've got arguments overall, split into 2 categories, deductive and inductive. This has to do with the degree of support that the premises are taken to provide the conclusion. Then we've got the first test, which is going to split both of these into 2 categories, passes the first test or fails the first test. If a deductive argument passes, it's got a good inferential relationship, that's valid. If it doesn't pass, it's invalid. For inductive arguments, if it passes, if it's got a good inferential relationship, then it's strong. If it doesn't, then it's weak. Okay? Then we can move on to the second test, which is, are the premises all true? So if we have a deductive argument and it's valid, and all of the premises are true, then it's sound. If it's valid but the premises aren't all true, we'll just say it's valid but not sound. Okay? If an argument is strong, an inductive argument is strong and has all true premises, we'll say it's cogent. If it's strong but it doesn't have all true premises, we just say strong but not cogent. Now you might wonder, hey, is there a word for an invalid argument that has all true premises, or a weak argument that has all true premises? No, because once you know an argument is invalid or weak, it doesn't matter. That argument is completely worthless if it's invalid or weak, so it doesn't matter if the premises are true or not. We don't want to waste our time with that. Now this is a lot of stuff, but the good news is this is what we're going to be focusing on, especially for the first 4 chapters, basically 2/3 of the course. We're not going to worry about inductive arguments. We will a little bit in 5 and 6. But the first 4 chapters, it's all deductive, and we're not going to care about soundness. We're only going to care about distinguishing valid from invalid arguments. That's it. Right here is where our focus is. So with that in mind, here's what we're going to be doing. If validity is a function often of the formal features of an argument. So for instance, here's the pizza argument, and here's the form, either x or y, not y, therefore x. Okay, I tried to tell you that this is why that argument is good. It's because of this form. Any argument that has that form is going to be valid. So when we're studying validity, we're not going to be studying arguments that have all of the sentences filled in. We're going to be studying forms like this to determine if this is a valid form, which is going to save us a lot of time, because then instead of having to sort of go through every one of the infinite arguments that has this form, we just study this form. Is it valid or is it invalid? And then we know for any possible sentences that fill in these variables, that argument will be valid or it'll be invalid. So here's what we're going to do. This is sort of the roadmap for the next, for chapters 1, 2, 3, and 4. The first thing we're going to do is develop means to determine the argument's form. How do we move from this to that? From the argument either in terms of pizza or in terms of a rabbit running down trails. Both of those have the same form. How do we turn the English into something like this form? It's not going to be exactly like this. We're going to have more symbols. But that's step 1, is to get the formal representation of an argument. Then step 2 is going to be, once we've got a formal representation, this is chapter 1, by the way, getting the formal representation. Then in 2, 3, and 4, we're going to be looking at different ways of determining, once you've got the formal representation of an argument, whether that argument's valid or not. Okay, that's it for section 1.1.